programmed by the rule-based mechanism. And AI is a concept. It's simulating human intelligence and generalized knowledge from large amount of data, and then to solve some kind of problem. And there are three concepts we hear a lot. One is AI, one is machine learning, and one is deep learning. And the relationship between these two concepts are inclusive. So AI is a very broad term that describes intelligent machines can simulate human thinking capability and behavior. And machine learning is an application or a subset of AI that allows machine to learn from data without being programmed explicitly. And deep learning is a main subset of machine learning, in which multi-layer neural networks model to work like the human brain, i.e. learn from large amount of data. And since today we mainly discuss the application on e-commerce apps, I will go a bit deeper into machine learning glossaries, since we use machine learning a lot in most of scenarios. For machine learning, there are two main training techniques. One is supervised learning, another is unsupervised learning. So the main difference between these two is if you're going supervising the training data set, meaning in supervised learning, you tell the computer each data set mean what. But for unsupervised learning, the computer doesn't need to know each data set mean what. So for example, you want to let the computer, the machine, to justify if an image is a cat image or not. For supervised learning, you give the machine a lot of image of cat and label each of data set as cat. And next time you give a new image of cat, the machine knows, oh, it's a cat. But for unsupervised learning, you just need to give a bunch of stack of images to the computer, and the machine will automatically cluster the images with similar objects. So the system, the machine doesn't need to know if the image is a cat or not, but next time you give a new image, it will relate to the similar object images. There are two models we use a lot in supervised learning. One is regression. Regression is to predict continuous exact numerical output. For example, if you want to predict the possibility of a customer, if he's going to purchase again next month, then you just need to analyze the customer's characteristics and historical shopping behavior. Then you will get the output if the customer is going to buy and how much he's going to buy next month. Another model we use a lot is classification. We see that every day in the email filter. So email filter is using classification algorithm to justify which email is spam email and then which one is ordinary email. For unsupervised learning, we see that most in the apps we use daily. For example, in the e-commerce apps, we see the just for you section, right? The apps will recommend some products just for you based on your own personal historical browsing behavior or clicking behavior. Similar to that, YouTube or Facebook also has the personalized experience. So during my sharing before, especially with some students, some people are worried, oh, if I can still find a job, since AI is so powerful. So good news is that not all problems can be solved by AI. There are so many wiki problems that even human or machine cannot find any effective solution yet. For example, poverty or global warming. And then there are some problems can be solved by mathematics or physics, for example, astronomy. And then there are some can be solved by computation. And AI is only covering small range of problems. However, if your current work contains one of these criteria, then it's time to rethink how to transit your career, because this kind of job can easily be replaced by AI. First, if your job needs few information, or if your job, the decision-making process is very simple, or you are mostly doing independent work, you don't have much collaboration with other people, or the working process is the same, repeating it again and again. So if your job contains one or more of these criteria, then yeah, it's really good time to think what you can do to transit your career in the future. However, if your work contains one or more of these criteria, then it's really hard to be replaced by AI. Number one, if your work is highly relying on social communication, for example, diplomat or negotiation expert, or like us, UX designers, because we need to talk to the business and users and stakeholders every day to make the right product or service. Or if your work depends on the creativity, for example, artist. So some people might say, oh, we are already seeing a lot of AI products that can write music or can produce some sort of art. But I would say the core of an artist is to resonate with people, right? To connect with people. And that really needs your own life experience and emotional expression. And a machine doesn't have that. Machine doesn't have life experience. So if your work is highly depending on creativity, then I would say AI can hardly do that. And the last thing, if your work has very complex environments, since AI or machine can only do, is very good to do one dimension of task. For example, we have seen some videos from the Boston Dynamics robot, right? The robots can dance, can walk like people. But if you ask the robot to communicate with people at the same time or do some other complex tasks at the same time, then for now, the machines cannot do that yet. And as human, we are born with many dimensions of sensories. We can do many different tasks at the same time just by training. So if your work has complex environment, then it's also hard to be replaced by AI. One of my major projects right now is SmartUI. So we are already seeing the personalized content in many of the apps we use daily. But we also believe that different users have different preference for the user interface as well. And for that, we divide the user interface into 3 layers. One is copywriting, the second is image source. The copywriting meaning the text on either banners or the product title, etc. And the image source could be the banner itself and the product image, if it's a white background image or showing how people use the product in the real illustration. And then the bottom, there is the page layout. Some people might prefer one product in a row, which is much more cleaner. And some people prefer more efficient scrolling, like to show multiple products in a row. And how we do that engineering, since each user has different profiles, right? Based on their characteristics. For example, if you're female or male, or how old are you, and if you're living in big city or suburb. And then there are some in-app behaviors. What kind of categories normally you like to click? And then there are some environmental information, like if you are using the app during daytime or nighttime, if you have good network. And all this information will be input to the ADI design system. And design system will output design token to front-end UI solution. The front end will adapt the interface accordingly and presenting to the user. For example, if you are high-end user, you like to shop luxury goods, we might show you this kind of interface. Or if you are a trendy person, you always follow on the latest products, we might show you this kind of information, this kind of UI. Or if you are an economical user who like to compare the price, we might show you this kind of UI. Another AI project I have been working on is Luban Smart Banners. So a few years ago, we released a feature to our sellers. And making banners are very tedious for graphic designers. And since the banners can only be used for a certain amount of time, it's mostly promotional banners, right? machine is very good to take this task because it's one-dimensional, right? We just need the product picture. We can cut out the background and just leave the product itself and find the template that can match the product the best and generalize tons of banners every day. So we have been doing this for some years now. And in the future, we'll continue to improve the product by offering each customer unique templates. So similar to the SmartUI project, we believe each user has preference on the design presentation as well. So each product will have different presentation or visualization to the customers. For banners, there is also an important part, which is the copywriting. So Alimama has the capability of generating the best copywriting for the customer to get clicks. So based on the category and based on the templates, we can produce the automated copywriting accordingly. Another feature we have is to generate smart videos. So we see videos every day, right? And when we ask sellers to upload some product videos, normally what they get is a very long branding advertisement video. It could be 1 minute or more. And not all the customers can stay until the end to watch the entire video, and they might miss the important product information, right? And what we do is to detect the part that can show the product the best. For example, this one, only 5 seconds, we show that on the product video. And we also have many shopping live streams daily. And it will be waste if we don't reuse this kind of video resource. So we can automatically find the live stream clip that can present the product, because one live stream could contain the illustration of many different products. So we select the part that relates to the product itself and show that on the product detail page. We also have the feature to auto-generate videos from a lot of product images. And talking about videos, we cannot leave the music out. Music can be really important to the video atmosphere. So we have the smart music matching system. So based on the product label, we can find the music style that match the product label most. For example, this one, we might find some music like this. And we might not have a lot of copyrights for music. So we also have the music generation system. How we do that is we get a lot of music sample data set, and we train the model using GAN model, and we apply the basic music theory to the model. And the algorithm will output the single tracks, either in piano or bass or drum or guitar. And we use the multi-track music harmonization algorithm to make the final output. For example, this one might sound like this or this, or it could be this. So during our design process, we thought about how we know the capability we have right now and what are the levels we need to follow up the next in the next phase. So referring to the auto driving car industry, which they level the different levels of autonomy. We also have the levels of ADI. So level 0, there is no autonomy. Designer produces everything, and I believe a lot of things are still doing that. And level 1, the machine has some basic assistance to designer. For example, recommending similar existing design to the designers. And level 3, machine can generate part of design by simple rules, which is design guidelines. And level 3, machine can generate most of design by human configuring a few parameters. Level 4, machine understand user needs and auto-generate design according to user-specific needs. And level 5, entire design, including interaction and visual design, comes from the machine learning. And right now, our projects are around level 3. So transiting to AI industry isn't easy for designers because we naturally have different mindsets with engineers. And that's something I heard from an engineer before, that you, meaning designers, you make designs that we cannot build. And we make things that nobody uses. That tells the gap between designers and engineers. And as designers, we are very familiar with design thinking process, right? We explore the problem space first, and then we explore the solution space. Or the user-centric design process by finding the specific UX problem or user profile. We go through the discover, define, develop, and deliver process. And this is the basic machine learning process look like. So first, we need to acquisite a lot of data set. And then we need to clean the data. And that's a really important step because that's going to help us to get a more accurate model. And yeah, we spend a lot of time here. And then training the data set. And training machine learning model, testing the model, evaluating model, and finally deploying the model. But I think for designers, if we can know more about machine learning, then it will be very helpful for us to better collaborate with engineers or to make the better service for the users. So it's not super different from how human learn something with the process of machine learning. So this is how human intelligence percepting a new thing. When we were little babies, we learn by a lot of samples and examples. We do, we induce and we do the sorting, we do conclusions. And then all this will become our knowledge and experience. And next time when we encounter similar events, we can make the reaction accordingly. And this is a process of machine learning. So from larger amount of data, and by selecting the right algorithm, we can train the model. And next time when we give the machine a new data set, you will have the output accordingly. So what machine learning can do for our projects? There are 4 application directions normally for machine learning. One is predict. For example, the example I said to predict the customer's shopping behavior or to predict a company's stock price based on its historical stock price and the financial report. And then there's personalization, right? You see that in shopping apps or social apps or content apps. And then there are recognize and detect. For example, voice recognition, face recognition, fingerprint recognition. We already have those kind of features in the phone we use daily. And then machine is really good to help with the data analysis. So if you want to find some patterns that human can hardly finish, then let machine do that. And exactly what machine learning can do for designers. I think for now, many of the designers, we do a lot of guesswork based on the research result, right, from with a couple of users, or based on the knowledge from the business. We do certain assumptions. However, machine learning can definitely help us with the user research. By analyzing the data, we know that in which context does normally user do what to find behavior patterns. And also with design system management. For example, the machine can automatically find components or style that didn't follow design system. Or design generalization. Like in the SmartUI project I introduced, it can do personalized UI as per user need. And what designers can do for algorithm? Well, designers, we do designs, right? So we can design interactions to better train recommendation model. For example, in the Taobao app, when you long press product card, you can tell the algorithm that you are not interested in the product. So next time, just for you will not recommend similar product, this kind of product for you anymore. Or in YouTube, when you press the icon on a video card, you can tell the algorithm that you are not interested in this content, or please don't recommend this kind of channel for me. And number two, we need to help users understand how system runs and build a trust. In most of circumstances, we don't need to tell users detailed of a lot of details of how the algorithm runs, right? Because even users won't understand. But there are some special circumstance that we really need to let user understand a lot of details. For example, if you are making algorithm to tell a doctor if a patient has a tumor or not, then the doctor really needs to know if your algorithm is purely based on a lot of medical, a lot of tumor patients' images, X-light images, or if your algorithm is also looking into this patient medical history or his own living habit, because the result will help the doctor to make the decision to tell the patient if he has a tumor or not. So in Twitter, we see some posts that from people that we didn't follow. And in this way, the design tells me that, oh, because Elon Musk liked the post and I follow Elon Musk, right? So help user to establish proper expectation. And if you press on Facebook card, and you wonder if you are seeing this content, why you are seeing this content, then you have the option to look into the details. And similar to that, Gmail also has the function when you click on the spam email, you can know why this email is being labeled as spam email. And number three, design when and how to collect data. So machine needs a lot of high quality data to train itself. And how do we get this data, right? We need to think about what kind of data we need to collect from the very beginning. And designers, we need to design ways of collecting data that feel like a natural part of the user flow, so the user doesn't feel offensive. And number three, we need to get a good data to help the machine have a more accurate recommendation or training process. For example, this is all the dimension of data I listed for the SmartUI project. However, not all of the data are very important for the final UI solution. So I selected a few of them and give it to the data scientist. And if you have a good analysis of user behavior from exact the point where you collect data, then you might give a good solution of what is user thinking right now and give the related service to the user. For example, this one, when user scrolled a few screens and the algorithm is guessing, oh, I might look for this kind of category. I might look for this kind of product. However, transiting to AI industry isn't easy for us. Number one, the machine learning has the nature of uncertainty, and this is very difficult to prototype for UX designers. So for engineers, they normally use two kinds of toolkits to during the machine learning process. One is machine learning as a platform. This kind of online platforms shares computational resources across multiple users. And number two is the programming toolkit like TensorFlow. And for designers, we are very used to graphic UI tools or interactive tools. So it's very hard for us to do the prototypes yet. And secondly, the traditional personas is difficult to apply on machine learning process because each user has different profile these days. If you are making a product for millions of users, for example, e-commerce apps, right? Then how can you do personas today? Because each user has different one. And machine can generalize solution according to each user profile. But this kind of profile is very hard for a human to map out manually. So yeah, we are still looking into that. And this is from MIT researcher, Yang Qian. And she listed all the difficulties UX designers might encounter during the design process. From the very beginning, that we might not sure what UI can do and what AI cannot do. To we cannot prototype AI system behavior. To the last, like if AI has some errors, who should be held accountable? However, going forward, I still recommend designers to expand your own knowledge map and to master some basic vocabulary. There are some links I recommend. For example, these two links. It's collections of many different resources just for designers. And you can get good knowledge there by browsing through different readings websites. And then there are some books. Machine Learning for Designer is a very short book to let designer know the basic concept of machine learning. If you have one day off, I recommend this book. It's not long. And there is Google People Plus AI Guidebook. They have a lot of good research results, and for designers who participate in the AI projects, how can you be more user-centric? And if you want to be more and more expert in the AI industry, there is a roadmap. And then there are some YouTube playlists. This one, AI Plus Design, and this is a full machine learning course by Andrew Ng. So if you want to learn mathematics, go and watch there. And number two, we need to be more involved in data analysis, help define the success criteria for the user and business. So for designers, I suggest that we need to be more comfortable with quantitative data, because machine communicate with numbers. And when designing for a system that learns, we encounter numbers and probabilities that will guide its decisions. As designers, we need to translate these numbers in a way that supports our users' goals throughout their journey. For example, this one is the dashboard I got from the SmartUI project. And by analyzing the data, which one is performing better, which one is performing worse, I have a better understanding of what kind of user profile prefer what kind of UI solution. And number three, incorporating machine learning into the design or the design process if it hasn't existed yet. So we can definitely start adding AI as a tool or machine learning as a tool to help us with user research or data analysis or improve our design efficiency or even do auto testing UI. If your product has not added machine learning or AI yet, try to think if you can add personalization or if you can add some feature to predict user need. And number four, take control of the final output interaction with users. So there's some edge cases that we might encounter during the final output. For example, this hilarious example in Siri. How do I tell my mom I'm gay? Here is your message to mom, I'm gay. This is a bad example, meaning the product manager or designer didn't think of this kind of edge case. Or in this one, after the user uploads a photo, the system tells an error that it doesn't meet the criteria because the subject eye is closed, only because he's Asian, right? So the AI system will never be perfect, and we need to consider as much edge case as possible and really do a lot of testing. And how we design the graceful failures will determine the final experience with users. And last, inclusive design, right? Microsoft is very good at doing that. So they have listed the bias for AI from 5 dimensions. From dataset bias, if you're using a training dataset, does the sample include everyone in your customer base? Or association bias. When training AI algorithms, human bias can make their way to machine learning. So if you're presuming a nurse is a girl or a pilot is a male, then it means your algorithm has association bias. Or automation bias. For example, we see that in the beautification apps, there are many products do beautification by the traditional European notion of beauty, like lightening the skin tone, right? And that is offensive for African users. Or interaction bias. There might be some users that deliberately input racist or sexist language into chatbot, for example. And then you need to identify these cases and to avoid your chatbot to train itself and iterate itself from these bad samples. And last, there's confirmation bias. For example, in the recommendation model, the algorithm also needs to take a lot of some other information, but not only reinforce the algorithm by by the user's historical behavior. And accessibility, Apple has done some good cases during iOS 14. This example is what they did for the disabled people who have hearing problems. So when the phone hears some strange sound from the house, for example, if the water is running or fire alarm is ringing, then you will alert the user that there's some strange sound happening in your house. Or this example, if the FaceTime detects the user is using sign language, then the FaceTime will zoom in to show better on the user face and hands to the other user. Okay, so I think that's mostly what I want to share today. Designing AI products definitely poses an exciting new challenge for us. And no matter if you are adapting your design process or adding new features to your product, we can utilize machine learning as a strong tool to create more awesome products or service. And if you have more thoughts about the relationship between machine learning and UX, don't hesitate to leave your comments on our LinkedIn or Facebook group. Okay.
All right, thank you, Youran. I think we only have one question, which is from David. I think his question is: are these open source? Yeah, hi. Hello, Youran. Can you hear me?
Yeah, I can.
Yeah. There's one question only. So I think the question is very generic. His question is: are these open source? I don't. Which items are you referring? If are they open source?
Open slots.
Open source.
Open source. You mean the slides or any links I put here?
I think you should be referring to the links.
The links, yeah, I can send the slides.
All right. Okay. So the slides, I think we will answer that. Yeah, the slides will be shared later, just for informations. Again, this of course this playback will be readily available also later on YouTube itself. Again, let's leave like 10 seconds more for any more questions for anyone before we end this session today. All right, we have one question: how long and how much data set is required to train the AI? How much train
How much
data set?
is required to train the AI? I would say a lot, as many as possible, because from small range of data set, you don't need a machine to train. You can analyze by human. So depending on the domain you are working on, and there are a lot of open source data sets online already. For example, if you are doing some projects similar to SmartUI project, and you can get some open source UI data set already online. Rico is one, and I think there's the other one contains a lot of Android screenshots. So there are a lot of open source data set already online, and include those open source data set in your training process first, and you can still collecting the new from your existing user base, of course, under the terms of privacy, right? And how long? I think it depends on your data scientist team. So it's depends on how many computing resource you have. It could be 1 day, 2 weeks. So depending on the scale of your project, yeah. But it's a continuous process. You always need to make the model more accurate.
All right, thank you. All right, it's a last. I think we'll answer this question. The last one. What type of trained data set? What type of trained data set for prediction? How to know if the AI prediction is accurate when it is trained?
How do we know the data set is accurate? Well, normally during the training process, we have a library of testing samples. So normally we divide the data set into the training samples and testing samples. And we use the model from the training samples to test on the testing samples. And well, we can analyze the result from those testing samples first. And then for designers, we can bring the product, the algorithm to simulate with real users to see if it's good enough. And during the release of AI product, normally it takes lots of testing. As I said, we need to consider a lot of edge cases. Yeah, I think a lot of testing is definitely needed to know if your model is accurate or not.
Okay, thank you very much. Okay, last questions. Will Alibaba Group work with companies? I don't know if there's any business opportunity. I think he's working probably like business opportunity and stuff. Is there any email alias they can connect?
Sorry, I didn't hear clearly.
Yeah, the question is, will Alibaba Group work with companies? I don't know how it.
Work with, of course, we work a lot of different companies. Yeah, of course. There are some products we collaborate between different departments. For example, for my department, we are sitting in the front end technology department, and we collaborate with some shop recommendation department to get the product recommendation on the page. Right? So we have a lot of collaboration internally and externally.
Okay, yeah. Okay, I think that's all of our questions. Again, thank you, Youran, for sharing today, and thank you everyone for your time today on Friday evening. Again, so have a great weekend ahead, and then have a good Friday. Thank you again. Thank you, Youran, for sharing her insight and her knowledge as well. Thank you.
Thank you, Wei Long. Thank you, everyone.
Thank you.